Alright, hi you guys, welcome. Implicit differentiation. Now, so far we've just done differentiation with respect to x when there was only x in there. Now if you wanted to do implicit differentiation with y in there, if you notice we had it all set up to y equals. And if you can get y equals alone, just use regular differentiation. Now if we try to do it here, if we try to get y alone, we're going to get a plus or minus version, which does not give us an exact answer. So we're going to have to do what is called implicit differentiation. So what you do is you actually go to both sides and you differentiate with respect to x. So you go differentiate dy dx of x squared plus y squared, and you treat it like its own function. D dx of 16. Okay, so you treat it like this. Alright, so now what you're going to do is you're going to almost, it's kind of like distribution, but then when you distribute, you do differentiation. Okay, so when you do the derivative of x squared, that's just going to become 2x, so that's pretty simple. Okay, now when you do the second one, that's going to become the chain rule because you're doing a function inside of another function. So this is going to become 2y times dy dx, and that equals now the derivative of 16 is just going to be 0 because that's a constant. Okay? Alright, now once you do this, once you start getting dy dx's, try to get this and isolate this alone because that's the implicit differentiation idea we want. Because in the very end, and I always like to explain this to my students, is if you try to isolate a variable, you'll do a lot better. Okay, so this is what we want. We want to get that alone and we're good. So we get rid of the 2x, and so we're left with 2y times dy dx equals negative 2x. Okay, and then if we divide both sides by 2y, we're going to get negative x over y. Okay, and it's totally okay to have the x and y in that form because later on you'll be able to use this stuff just to be able to work with it. Okay, and let's go to the next problem. Alright, now just practicing this stuff is just going to make our job a whole lot easier. So let's say we wanted xy minus x minus 3y minus 4 equals 0. So I just got this problem. A wonderful gentleman on mathtv.com showed this problem, and I just thought it was a good one to show you guys because you can't explicitly get x alone or y alone. Okay, so what you do first is you do derivative with respect to x of both sides, and so it's going to be xy minus x minus 3y minus 4 parentheses equals d dx, derivative with respect to 0. Okay, and you just do the differentiation of both sides. Now this first one you're going to do is going to be the product rule, and then the subsequent ones are going to be pretty easy to work with. Okay, alright, so the product rule is going to be the derivative of the first one, no, derivative of the second times it, so it's going to be x times dy dx, derivative with respect to y, okay, plus the first one, which is y, okay, or the second function, which is y, times the first derivative, which is 1. So that's that first part, so that's pretty easy. Okay, then we do the second part, so that's going to turn into just minus 1, so that's pretty easy too. The derivative of x is just 1, so we put the minus right there. Okay, then the derivative of 3y is going to be 3 times dy dx. Okay, so that's huge right there. And then the derivative of negative 4 is going to be 0, so we're just not going to write that. And then the other side is going to be 0 as well. So we're left with this. Now if you notice, I have two dy dx's. Okay, if I isolate these two, I know what the derivative, the implicit differentiation of this problem is. So I'm going to put those two together. Oh, and this should be a minus sign in between. Sorry, I forgot to write the minus sign. Okay, so that should be a minus 3 dy dx. Okay, and so what we're going to do is factor that out. We're going to put those two together and factor it. So x minus 3 times dy dx. And if we factor out this way, it makes our job a whole lot easier in understanding what we're doing. Okay, and then plus y minus 1 equals 0. Okay, so we start to isolate dy dx, so this becomes parentheses x minus 3 times dy dx equals 1 minus y. Okay, and then we divide both sides by that, and so we should get dy dx equals 1 minus y divided by parentheses x minus 3. And once again, it's okay to have it in terms of x and y because it's going to be fine. Okay. All right, let me get the other problem. Okay, so let's actually start combining this stuff with actually finding some information. So let's say we wanted to find the equation of the line tangent to y squared equals x cubed parentheses 2 minus x at 1 comma negative 1, and that's going to be important because that's both an x and a y. Okay, so once again, we do everything with respect. Okay, so this is going to be d dx of y squared. Okay, and that's going to equal d dx of x cubed times 2 minus x. Okay, so it's going to be set up like this. Okay, so what we're going to do is we're going to do the derivative. So this first one's going to be the chain rule. So it's 2y dy dx. Okay, and that's going to be times between them. And I write the times just so you guys understand that it's like a variable, but some people forget it that it is a variable. Okay, now what you can do for this next one is, if you notice, it's a number in front of parentheses and you can distribute. If you'd like to practice the product rule, that's totally fine. I'm going to distribute and just do it. Okay, so this is going to turn into 2x cubed minus x to the 4th. Okay, so I'm going to do the derivative of that side, which is going to be pretty easy. It's going to be 6x squared minus 4x to the 3rd. Okay, so I get that all set up. Now, just to get everything all set up and finalized, I go dy dx equals parentheses 6x squared minus 4x cubed parentheses all divided by 2y. Okay. Okay, so what I'm going to do next is I'm going to recognize the fact that I just want the equation of the line tangent at 1, negative 1. So what I'm going to do is plug in a negative 1 right here, and I'm going to plug in a 1 in each one of these spots. Okay, and so dy dx is going to be equal to, on top it's going to be 6 minus 4, because the 1's really don't affect anything, divided by negative 2, which is going to equal negative 1. So the slope is actually going to be negative 1 at that point. Okay, and that's how you do implicit differentiation, and especially how you find an equation of a line that is tangent to a certain type of function at a certain point. Thank you very much and have a great day. Bye.